So this video will show us how to work out volume of prisms. But first off, we're going to have a starter here. So put a timer of 10 minutes on your phone, pause the video and have a go at these questions. So let's have a look at the answers. I'm just going to quickly run through these. So first question, we've got 8,305 plus 1,956. Use that column method. Make sure we line up each digit. 11 for the first one, so carry the 1. 5 add 1 is 6. 9 add 3 is 12. Putting the 1 over there. 8 add 1 is 9. Plus another one, we've got 10 there. So our answer is 10,261. Next question, we've got 4 cubed. What does that little 3 mean? It means we've got to times 4 3 times. So we've got 3 lots of 4. We've got to times that. 4 times 4 I know is 16. 16 times 4 is 64. So that's our next answer. Find the area of the triangle. We've got to remember that base times height divided by 2 is our formula. And now let's just plug those numbers in. Base is 20, height is 4, and I've got to divide that by 2. 20 times 4 is 80. 80 divided by 2 is 40. But for that extra sort of mark, so to get full marks, you would have to put centimetres squared because it's an area. Okay, moving on to the next question. Put these measurements in order from largest to smallest. Well, we've got to notice some are in grams, some are in kilograms. I'm going to change all of them into grams. How am I going to do that? Well, I've got to remember that 1 kilogram is the same as 1,000 grams. So 2 kilograms will be 2,000 grams. That one's already in grams. 0.9 kilograms, slightly trickier, but we see to go from kilograms to grams, we're timesing by 1,000. So that's actually going to be 900 grams. This one's in grams, so that's fine. And then this one again, I'm going to have to times by 1,000 to make it to grams. So we're going to get 90 grams. Right, I've got them all in grams now. Let's put them in order. Let's check the question. I've got to go from largest to smallest. Well, the largest is 8,000. Cross that one out. Now what's next? Well, the next one's 2,000 grams, isn't it? But that one started off as 2 kilograms. So I'm going to just put that underneath. Cross it out. Next biggest one, we've got 975 or 90. Well, 900 grams, which actually started off as that 0.9 kilograms. Cross that one off. Last two, well, the 90 grams is bigger than 75. So that should have been your answer for that one there. Let's just make sure I put down what it said in the question. There we go. Last one. William's thinking of two numbers. Both numbers are square numbers greater than 1. The sum of the numbers is 100. Write down the two numbers. Well, I know both of them have to be square, so just to help me out, I'm going to write the first few square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So 16, 25, 36, 49, 64. Okay, so can I choose two of those there that add up to 100? Well, if I have a look at 36 and 64, 36 plus 64 does equal 100. And so it says the sum of the numbers is 100. He's thinking of two numbers, both numbers are square numbers, so my two numbers are 36 and 64. So today we're looking at volume of a prism. Well, first of all, what is a prism? We've got that definition under it. It says a prism has a cross section which is exactly the same shape and size throughout its length. Well, let's see what we mean by that. Here's a cylinder, and the cylinder is a prism. We know it's a prism as it has this cross section here. As you can see, that cylinder has been cut with a knife in half, and the cross section is that circle there. So we could see no matter where we cut that shape there with a knife, we're always going to have a circular cross section. So a prism is sort of like one face stretched one face stretch. So we've got that circle stretched all the way down. It's going to be the same throughout the shape. So we're looking at volume of prisms. Remember, volume is the space inside the shape. The formula we're going to need today is that green box there. Volume of a prism equals the area of cross-section times length. So make sure you've always got that formula in your head for today's lesson. So before we start plugging in numbers and finding the volume, we're just going to first be able to identify the two separate bits. So we need to be able to find the area of the cross-section, and then we've also got to find the length. So let's just have a look at these first two shapes here. Where's the area of the cross-section and where's the length? So remember, cross-section is the shape that goes throughout the whole prism. So here we can see the cross-sections there. On this first shape here, we've got a pentagon. That bit's shaded in there. Here's the cross-section, because if we cut this shape anywhere, we'd always open it up and see that face there. So that's the cross-section for that shape. And the length is how much it's stretched back. So we've taken this face here and it's just been pulled and stretched all the way down to there. So that's our length. And for the one on the right, our cross section is that triangle. Because again, let's say if I cut that shape there, we'd open it up and we'd always see a triangle. Okay, let's now have a go ourselves. So I've got to find the volume of this prism here. So it is a prism because it's got a cross section, which is that triangle which has been stretched. Okay, so just to remind myself, I'm going to say the volume is the area of the cross section times by the length, so times by how far it's stretched back. First of all, let's identify the cross section. Well, that is that triangle shape there. So the first part, which we're going to do in orange, is this bit here, the area of the cross section. Well, let's write on these bits there. How do I find the area of this triangle? Well, that's base times height divided by 2. Base is 8, height is 10, and divide by 2. 8 times 10 is 80. 80 divided by 2 is 40. 40 centimeters squared. So I've completed this orange bit of the formula. I've found the area of the cross section. It's 40 centimeters squared. The other bit I've got to do is times it by the length. Well, the length is how far it's stretched back, which is the 4 centimeters. So I can now put it all together. Volume equals area of the cross section, which I found out is 40, times by the length, which I found out was 4, and my answer is 160 centimeters cubed. So notice the unit. When we have volume, we're going to have centimeters cubed or meters cubed. Okay, so you see that pause sign there. That tells us that you need to pause the video and have a go at this one here. Let's go through the answer, see if we got it right. Remembering volume equals the area of the cross section times by the length. So always split this up into sort of two different problems. The first thing I'm going to do is find the area of the cross section. We've got the same shape, so the area of the cross section is that triangle. So I've got 8 centimeters as the height, 6 centimeters is the base. So the area equals base times height divided by 2, because that's how we work out the area of a triangle. Base is 6, height is 8, and we divide that by 2. 6 times 8 is 48, divided by 2 is 24. So the area is 24 centimeters squared. Remember, area is centimeters squared, but we're going to be able to work out the whole volume by putting it into this formula. So volume equals area of the cross section, which we've worked out as 24, and I've got to times it by the length. Well, the length is how far back it goes, which is 4 centimeters again. So our overall answer is 24 times by 4, which is 96 centimeters cubed. Okay, one more problem pair we've got here. Let's have a look at the one on the left. So remember, volume equals the cross section times by the length. What's the cross section this time? Well, remember, cross section is that shape that's been stretched to form the solid. Well, having a look at this shape, I can see that that front face here is the cross section. What shape is that? That's a trapezium, which we have been working on previously. Can we remember the formula to find the area of a trapezium? Can't remember? It's half a plus b, where a and b are the parallel sides, times by the height. So let's plug those values in. So half a plus b, so the parallel sides of this top side here and the bottom here. So that's 4 plus 6, times by the height. Height is this length here, which is 7. Now let's work this out. Half of 4 plus 6 is 10 times by 7. Well, half of 10 is 5 times by 7 is 35. So I found the cross-section area is 35 centimeters squared. Now I've got to plug it into the last bit. So volume equals the cross-section, which is 35, times by the length, which is 8. And so that gives us a solution of 280 centimeters cubed. Again, pause the video now and have a go at that question there. Okay, so let's go through the solution. I'm going to find the cross section and then I'm going to times it by the length. Same shape again, so we've got the same cross section there. Half a plus b times by the height, remember, is the formula to find the area of a trapezium. So half a plus b, well, a is this top side 6, b is that bottom side 12, times by the height, which is the 9. Half of 6 plus 12, which is 18, times by 9. Half of 18 is 9, and I've got to times it by 9. So we found the area is 81 centimeters squared. And remember, I've got to do the cross section, then times it by the length. So the cross section is 81, times by the length, which is how far it goes back, which is 7. So our answer should be 567 centimeters cubed. So it's now over to your turn. So you can see we've got question 1, 2, and 3. 1 is bronze, 2 is silver, 3 is gold. Notice with this bronze section here, it already gives you the cross-sectional area. So here it says the area is 15 centimeters squared. The green bit shaded in is already the cross-sectional area, so you'll just have to times it by the length. Don't forget about the equation. So cross-section area times by the length. So choose which questions you'd like to have a go at. Pause the video now and have a go at them, and then there'll be answers on the next slide. Okay, so here's the answers, all with units on there, so make sure you've included your units. I've added a few little notes just to remind you. So the area of trapezium, it gives you that formula along with parallelogram and the triangle in case you forgot. So now we're looking at something slightly tricky. We've got to find the volume of this shape. It's a little bit irregular, so it's not like a cylinder that we've seen before, but it's made out of a compound shape. So remember back, compound shape is made up of more than one, a shape made up of more than one face, more than one shape, so 2 or more shapes. So don't be put off. We're still going to use the volume being cross-section area times by the length. It might just take us a little bit longer to find the cross-section area. The cross-section we can see is this green highlighted space, isn't it? So it goes throughout the whole shape. How am I going to find the area of that? Well, I'm going to split it into 2 shapes. I'm going to draw a line here, find the area of this rectangle, which I'll call A, find the area of this shape here that I've called B, and add them together. Well, the area of A is going to be base times height because it's a rectangle. The base we can clearly see is there, 10. Well, what is the height, this length here? Well, we're going to have to look at the shape there. I know that from top to bottom it's got to be 10 centimetres, and I know this bit here is 5 centimetres. So this must also be 5, mustn't it? So 5 and 5 is 10. Yep, so the height is 5. So the area of A is 50 centimetres squared. What about B? B is also a rectangle, so we've got base times height. What's the length of this line here? Well, I know this one here is 3 from that bit at the back there, and I know the whole way across has got to be 10. So this base must be 7 in order to make it up to 10. So the base is 7. What is the height? Well, it's given us there, 5. So the area of B is 7 times 5, which is 35. So the area of the cross section is that shape A plus the shape B, which we get is 85 centimetres squared. Brilliant. Let's go back to our formula. I've got to do the cross-sectional area, which I've now found, times by the length. So the cross-section area is 85 times by the length, remember, is how far back it goes, which is this 14 there. You can use a calculator for these questions. So 85 times 14 gives me 1,190 centimetres cubed. So very similar example. Pause the video and have a go at this one. Okay, well done for giving that a go. Volume equals cross-section area times by the length. Let's start with the cross-sectional area. I'm just going to put on the missing values on this diagram here. So this length here is 2. What's the height of the whole shape? Well, we know that bit there is 10. What's the length there? That's 2. So the whole thing's got to be 12. That's going to help me out. So the cross-sectional area, I'm going to work out by splitting that compound shape into 2 shapes. I'm going to draw a line onto that shape here. Okay, so I'm going to find the area of that A shape and the area of B. A is a rectangle, base times height. What is the base? What is this length here? Well, looking all the way across is 12 meters, and up to this point here is 10. So from here to here, it's got to be 2, which means at the front here to here has got to be 2. So the base is 2 and the height is 12. So area of A is 24 meters squared for this one. B is also a rectangle, so base times height. What's this length here? Well, we know that's 2 and the whole thing's got to be 12. So the base must be 10 and the height is 2 meters squared again. So the cross-sectional area is those 2 shapes added together. So we've got 44 meters squared. So I can put into my formula here, 44 meters squared is what we found as the cross-sectional area. For the length, remember, is how far back it stretches. Well, the shape is an L shape stretched 18 meters backwards, isn't it? So our length is 18. Got those 2 parts there. Just going to plug it into a calculator now. 44 times by 18, and that gives me 792 meters cubed. Okay, final question now. So if you found this lesson quite easy, pause the video now and have a go at this tricky challenge question. So you've got both of the following prisms have the same volume. Find the missing length. So this L is missing. Pause the video, see if you can find out what it is. Right, well done for giving that one a go. Let's have a look at the answers. I know that the volume of, let's call this one shape A, has got to be the same as volume of shape B. So let's bear that in mind. Okay. Well, I know I've got to find the volume of each of them, so I'm going to do that separately. So let's do the volume of this one first. Volume of a cuboid we looked at last time, but we can also use the formula cross-sectional area times by the length. Well, the cross-section area is this rectangle here, which is 5 times 6. and the length that it goes back is L, which we're just going to have to put as L because we don't know it yet. 5 times 6 is 30 times by L. So the volume of that orange shape there is 30 times L. We could call that 30L. And we're just going to have to stop there for a minute because I can't do anything else for that one. What about this shape here? Well, the volume is the cross section times by length. How do I work out the cross section? Well, what shape is it? It's a trapezium, isn't it? Area of a trapezium is half A plus B times by height. A and B, remember, are the parallel sides, the 7 and the 4. So let's add those together. And the height is this 6 here. So we've got half of 11 times by 6. Half of 11 is 5.5. 5.5 times 6 is going to give us 33. So looking back at this formula here, we found the cross section is 33. I've got to times it by the length. Length is how far back it goes. Well, it's stretched back 10 centimeters. So the volume of this one is 330 centimeters cubed. So I've found the volume of A, I've found the volume of B, but the volume of B has this letter L. Well, let's go to the start where I wrote that both of the volumes have to be the same, and let's put in what we found out. We found that the volume of A was 330 centimeters cubed, and I found that the volume of the shape B, the cuboid, was 30L. So again, we've come to an algebra problem, and now we're going to have to try and solve it. So 330 has got to be the same as 30L, or 30 times L. I've got one thing unknown. I want to find what L is equal to. So how do I go from this step to this step? Well, the difference on this right hand side is I've times by 30. So to get rid of times by 30, remember you divide by 30. You do the opposite sign, same number. So on this right hand side, that's going to have cancelled those 30s out. We're left with an L, which is what we want. And on this right hand side, I've got 330 divided by 30, which gives me 11 centimetres. I could double check that that's right, because we know that the volume has got to be 330. So I could do 5 times 6 times by the 11, which is how we work out the volume of a cuboid, and that does give me 330. So really well done if you got that one. And that brings us to the end of the lesson.